Hello, everybody. Thank you for coming and spending your evening. I feel like this time we should be serving dinner to you all with this talk, right? Dinner and drinks. That would be cool. That'd make for a really cool talk. So let's see. Oh yeah. So you know what talk you're here for. So I'm just going to introduce myself really briefly. I'm Brian Rinaldi. I'm a developer relations engineer at Launch Darkly. Charity Managers is also going to be one of your speakers. She's CTO of Honeycomb. And that's all the intro you really need. So I want to start off with a really simple question. What are feature flags? Many of you may already use them, but some of you may not. I've talked to a lot of people today who haven't actually done much with feature flags at all. So many developers think there's nothing really special about feature flags. They're just a simple Boolean after all. I've talked to people who can't even believe there's a company that sells something based on feature flags. There's a whole company that does that, and actually there's more than one. And because developers tend to think, well, I could just build that myself. It's super easy, right? But feature flags are definitely more than just simple Booleans. Never mind that they don't even have to be a Boolean. They can be any kind of data type, right? But even a simple Boolean flag can be a lot more complex than it may seem. So I think more important than talking about what feature flags are, I want to talk about what types of things they enable, because I think when you adopt feature flags truly into your application development, it can dramatically change the way you build and operate. So as technologists, many of us have heard there's value in moving fast and breaking things. As you probably know, this was Facebook's official motto until 2014. They dropped it, actually. But many companies, especially early stage companies, seem to value speed over the quality of work. But in the end, it turns out that breaking things doesn't keep their customers very happy. So while there's definitely a need to move fast in the way we develop, the breaking things part is entirely unnecessary. In fact, data shows that some of the best performing companies move extremely fast in the way they develop. They deploy code to production multiple times a day and release frequently. And notice I said deploy and release separately, because that's a key point, which I'll get to in a moment. So how they do it? Skipping ahead. In fact, a lot of these companies will deploy hundreds of times a day, often moving code from when it's checked in to production in under an hour. And the way they do this without breaking things is by using feature flags. So this is because feature flags, as I said before, separate deploy from release. So just because something is deployed doesn't mean I've actually released it. It's not running in production or in whatever environment that I set. So this not only removes the risk from deploys, but it minimizes the risk from releases, because a feature that isn't necessarily working can just be turned off remotely, without rollbacks, without a redeploy. This separation of deploy and release can fundamentally change the way you build and operate. It can alter the way you build applications by enabling you to roll out changes progressively, say 10%, 20%, 30%, until you're sure that it's stable, and then you release it fully. Or you can release it to different groups. You can roll it out to different subsets of groups, targeting, like, say, a beta user group, or I could roll it out to Q&A, then a beta user group, then a larger group. I can roll it out regionally. And those kind of things really change the way they de-risk the way you deploy applications. The way you release applications. So Charity is going to get into that a lot more in just a bit. But feature flags don't just change the way you build things, they change the way your team operates by removing the risk involved in releases and giving the tools to prevent incidents from escalating and to measure the success or failure of a particular release. They also make complicated things like migrations less difficult, meaning your teams are going to be less hesitant to make necessary changes. So a lot of teams, sometimes that risk causes them to not make a change they should make. But if you can remove a lot of that risk, they'll make the changes they need to make and Charity will actually touch on that as well. So hopefully I've established that feature flags are awesome, but why do you need a service like LaunchDarkly? So the thing about LaunchDarkly is we have extremely high performance. You get 20 millisecond startup initialization time, 200 millisecond for updates. And the thing that's really cool about those updates is that those are constantly streaming to your application. So that 200 milliseconds is like that change I make in LaunchDarkly, it's going to be streamed out to all the connected applications. We are cross-platform. We've got 25 and counting SDKs that cover basically any language you want to use, or a framework and platforms that you want to use. We've got a flag delivery network that spans the globe, so that's partly how this works so fast, but we're on hundreds of CDNs around the globe. We have advanced features like user targeting, which is super powerful. We've got workflows, we've got experimentation, we are scalable, we're serving trillions of flags every single day, and we have a ton of integrations with the tools you already use, so you're not gonna have to adopt new tools necessarily. In fact, you can use it with Honeycomb, as you'll see. Plus, we've been around for a while. We were founded in 2014. We have over 4,000 customers. We're used by over 20% of the Fortune 100. So we've kind of proven ourselves as a solution, I think. So how does this work in real life? Well, that's where the fun part comes in. And Charity is going to talk about how Honeycomb we're able to use observability and feature flags together to do some really powerful things.
What does this look like in the real world? This is one of my favorite kinds of things to talk about. And by the way, I don't know why y'all are here. There are perfectly nice parties going on right now. But thank you. We are definitely not going to take the whole hour, as my friend said, but we are going to make sure and have lots of time for questions. So I hope that you will ask anything that strikes your imagination. Honeycomb, obviously, is a company that I am from. We are huge fans of feature flags and avid users. Sometimes I feel like I spend as much time trying to get people to use feature flags as I do observability. I have a sticker. Have you seen the one? Let me introduce you to my Lord and Savior, feature flags. I have one of those at the Honeycomb booth, and another one that is I don't know. I have stickers about feature flags, and I'm not even paid to do it. So I honestly don't believe that you can have an effective modern software delivery pipeline without both feature flags and observability. And you've probably heard the word observability a lot in the past few years, and most of it is it's baloney. There is a technical definition for observability, and it is not just like all the crap you are already doing that you want to slap a new word on. Observability is, I don't know, I've written a lot about this, so I'm not going to go into it now, but it has to do with, instrumenting your code for high cardinality, high dimensionality events, tracing so that you can inspect it and ask really complicated, interesting questions about what's going on inside your software. And there are a lot of use cases for how Honeycomb uses LaunchDarkly, but we're going to talk through two in particular. One of them is. The backdrop for all of these stories is that we've been under some pretty relentless growth over the past few years. You double and you double again, and so our practices have had to scale a lot at the same time. So the first example of of how we use feature flags and observability that I'm going to talk about is one where, so in Honeycomb, we've got these derived columns, right? You can, if you define data type, you send in some dimensions, and you're like, ooh, I want to do math with these after the fact, and you can create derived columns. And it famously, it was really hard to use the derived column editor. So our front-end team came up with a new one. How do we deploy it? Do we just drop it on everybody? Like, that seems confusing. It's a pretty complicated, piece of technology. So we used feature flags to do this. And the amazing thing about using feature flags to deploy your code is that it's not a big bang. You can have your old code and your new code running concurrently. You can say start redirecting only your internal users or only your developers to start banging around in the new UI. And then if it seems okay, then you can slowly open it up to say a group of alpha tester customers or beta tester customers, or if you're pretty sure that you've got the use case down for a certain type of customer, you can turn it on for all of them. You just have a lot of really fine-grained control over how your code gets rolled out into the world. So, and the teams themselves, right, are always going to be the ones who are in the best position to understand the impact of the release of their code. It sucks if you've got an engineering team who are like spending all their time and design and everything. They're spending all their time trying to figure out how to solve this problem. And then when it's like, okay, I think we have something, what? They just like toss it over to an SRE team or some other team to deploy it and that's just a recipe for everyone getting paid in the middle of the night. No, you want to roll this stuff out during the day, right, while you can watch it, while you can look at it, and then maybe you want to roll it back at night if you don't have confidence in it. The awesome thing about feature flags is it really helps, it helps close the loop and connect the dots and help complete that transition of helping engineers actually own their own code in production. What that looks like, this is a stylized version of the Honeycomb graphs, but this is basically, we have all the events, we break down by build ID, and you can see us using the requests to the derived column builder. The older one is getting used less and less, and the new one is getting used more and more. Pretty cool, pretty straightforward. The next one we want to talk about is a little bit more complicated. This is when we had a new implementation of our ingest code, and ingest is where we make the biggest promises to our users, right? We want to get it out of the RAM in your machines and written to our disk just as quickly as possible, within milliseconds if possible, and so we really, in terms of SLOs, this is the SLO that we really don't want to mess up. And there's Doug's quote. And here you can see the percentage of, Shepherd is, we name all of our backend services after dogs. Shepherd is our API service. And you can see the percent of traffic that's flowing through Shepherd for the old ingest path versus the new ingest path. And in fact, we started to see pretty quickly that things were not going ahead according to plan. And the nice thing about this is we don't have to then go change some code and deploy it again. We just flip the flag and undo the stuff that we had done. The last one that I want to talk about is the most interesting one. Now, I think we often think about feature flags as being something that we can use to help us with, debugging or deploying things that are very customer impacting, right? And there's all the arguments about, should I test in production? Should I test in staging? What? A lot of this argument leaves out the entire fact of backend development and the fact that we too make changes that are much harder to, say, isolate and cordon off and do very gracefully. And feature flags are amazing for this, too. This one is one that I want to talk about where, so those of you who follow Liz Fung-Jones on Twitter have probably heard her whole saga about testing out Graviton stuff for AWS, right? Graviton is one of the keywords that we put in this talk title that helped us get submitted. But all you need to know about this is that, well, maybe you need to learn a little more. All right, so like never write a database, first of all, never write a database. We kind of wrote a database. Our query planner actually exists in Lambda jobs. So whenever, data comes in, gets written out to Kafka, and then we've got these pairs of retriever nodes that slurp it out to Kafka, write it to disk, and then when you issue a query through the UI server, it does this fancy thing where a Lambda job actually like fans out and does this massively parallelized read and merge and returns results to you in like it's really, really freaking fast. Like people are always really surprised because I think that our SLO is for like the 95% of all queries to return in under like 2 seconds. Like it's really fast. So we're like, okay, Graviton's supposed to be faster, beefier, all these things. Let's like switch over our Lambda jobs to be run on Graviton. This should be pretty much, nobody should notice this, right? It should just happen magically behind the scenes. So, if you look at this, we split 50% of our traffic to be running on, Lambda backed by Graviton, and 50% still on, the old stuff. But when we looked at the latencies, they were really high. And this is expensive. Yeah, this is, pretty expensive in user experience terms, but honestly, it's still like a couple seconds. Most users might not notice it. But our Lambda bill, which may I remind you, charges per like microsecond that you're using the Lambda job, this like 50x star bill. So we rapidly backed that out. And we had very cavalierly switched this on, which you can do sometimes. If you have great tooling and great, observability, you can just like cowboy some stuff on the back end. And okay, we tried it. Didn't work so well. So next time, let's do this with a little bit more intention and grace and like safeguards and smaller steps. Yeah, and this by the way is exactly what it looks like in our Slack workflow. You just update the flag, bloop, done. So we try again, more slowly and safely this time. We turn it on for, also we had done some optimization under the hood before trying for the second time. We're like, ooh, we think we know this might be slower. We did some stuff, but then we're trying to roll it out in a much more contained and controlled fashion. I also want to mention the awesome ability that LaunchDarkly has to let you schedule feature flags so you don't forget to turn off your experiment accidentally. Not that that's ever happened to anyone. And as a result of all this, our ability to run experiments with these safeguards, like we were able to achieve the results that we wanted, wrote a bunch of blog posts about it, whatever. And things like rollbacks, which used to take seconds, with this workflow, or things that used to take a long time, now just take seconds. And the end result, of course, is that we saw a 50% reduction in cost per query. Honestly, half of this was changes that we needed to make under the hood. Half of it turned out that AWS just needed to provision enough Graviton capacity for us. There are a lot of other ways to use feature flags, which is not synonymous with LaunchDarkly. You can roll your own. We've done it before. LaunchDarkly, honestly, the thing about LaunchDarkly, feature flags, they're pretty basic. They're flags. They're not, but like what LaunchDarkly has done well is it made the user interface really tractable for non-technical users. I think this is really important because, well, first of all, I cannot emphasize enough that, if you're running a modern software pipeline, you have an absolute moral, technical responsibility to decouple deploys from releases, right? Because the motivations of these two groups, the needs, are diametrically opposed. As engineers, you need to be deploying constantly, lots and lots of small changes as quickly as possible. We have the slogan, 15 minutes or bust. From the minute an engineer merges their change into main, should kick off a CI/CD process, and then it should deploy to production. They should be able to go, they should be instrumenting their code. Within 15 minutes, they should be able to go and look at those changes in production and ask themselves, is it doing what I expected it to do? Does anything else seem weird? And you start saying this to a lot of engineering teams, and they're like, that sounds great, but also terrifying because they're right. There are lots of other people's needs when it comes to software delivery that this will just totally screw up their lives. Product people need to be able to schedule releases. Marketing you need to coordinate all this stuff. I mean, if you've ever worked someplace where it's like, okay, we're deploying that, we are going to launch this really big, important venture at 10 a.m. on Wednesday. Press is going to go live, all this stuff. Everybody's going to hit the site. And then you, as the engineering team, have to go, okay, so it takes us 2 hours to deploy. So we should start at 8. But what if it fails halfway through? Should we give ourselves enough time to try twice? But then what if it goes live a little too early? It's just this is math that should never have to be done, right? Not to mention, you're deploying new code and you want a bunch of people to pile on and use it right away. Are you mad? You know that your code doesn't actually work. You do not know that your code actually works until you've watched users using it in production for a while, right? Deploys are not... Deploy should never be synonymous with releases because a deploy is just a beginning of the process of gaining confidence in your code, right? It starts when you deploy. It does not finish. It does not finish there, but it doesn't start until you deploy it, right? So feature flags are the way that you give everyone can get their needs met, right? But if you decouple deploys from releases, if you remember nothing else from this entire conference, remember how important this is. You can't, all the fancy stuff we talk about with observability, microservices and all this stuff, if you don't decouple your deploys from your releases, a lot of it is just impossible or intractable or improbable or just can't really be done. I don't think we really emphasize that enough. Anyway, it's important. Where was I? Precision gives confidence. I've written many rants in the past about deploying on Fridays, et cetera. And the point is not to be religious about whether you should or not. You should, but the point is not that. The point is that you shouldn't not deploy on Fridays out of fear, right? If you feel so afraid of what will happen when you deploy your code that you're like, God, we may not have a weekend if we do this on Friday. Well, that is a very bad thing. That's a bad sign. You don't fix this by just trying to get away. If something hurts, you do it more, right? Don't do it less, do it more. And this doesn't come naturally to us. As human beings, it's hardwired into us that if things get scary and out of control, you slow down, right? You're like, whoa. And we have to really intentionally unlearn this, which is doable. You have to learn in your guts that for software, speed is safety. The more often you're doing it, the more boring it is, the more automated it is, the more, deploying should be a nothing burger, right? You should be scared of what happens when the deploys stop. The worst outages of my life have all happened after a holiday freeze. Guess why? Well, anyway, using feature flags to decouple deploys and releases. There we go. tightly coupled deploys and releases are at the root of it. I feel like the single largest source of technical debt in almost every engineering org is fear of deploys. It's not even the deploys themselves. It's the pathological behaviors and distortions that get generated by how afraid everyone is of it. And the other thing, I know I've been like talking up feature flags a lot here too, but like observability is just as important. Yeah, if you're shipping code that isn't well instrumented, that you only know if something's broken with your code if you get paged or somebody complains, then I completely understand why you're terrified to deploy your code, and you should be. But that's not the world we want to live in, right? We don't want to live in a world where we only actually get to understand if our code is working if somebody is mad enough to complain or if the breakage is at a threshold enough to wake someone up. Those are really big guns, right? And like if you're moving from like symptom-based alerting to SLOs, you can generally delete over 90% of your paging alerts and have a better experience for your users. But you also have to trade off the, I'm just not even going to look at it until I get paged. You can't do that anymore. You have to look at it every day, right? You're instrumenting your code, you deploy it, and you look at it before you move on, before you've swapped in, another project. If you look at your code right then and there, you will find most bugs. The cost of finding and fixing these bugs goes up exponentially from the moment that you write them. If you type a bug and you backspace, it's as fast as you're ever going to get. Second fastest is doing the equivalent of shipping it to prod and looking at it, right? Instrument, look at it. That's how you can have confidence in your deploys. I don't have time to talk about all that. But you're right, there are so many gremlins in your software. When we're rolling out Honeycomb, again and again and again, we have this experience where we're just helping folks deploy their instrumentation. We're just what's that? What's this? And they're like, oh shit, that's a bug we've been trying to find for months. It's just you're right, you should be scared. But you don't have to be scared. If you adopt observability and if you adopt these habits of actually, picking up the rock and looking under it, then the gremlins don't get a chance to nest there. Don't know where I'm going with that. Anyway, I think I'm almost done. I think I'm done. Yay. Thanks.